This video is called Create ML for Everyone. And it's my goal to try and walk you through all of Apple's machine learning platform with lots of specific code examples so you can really apply it all to your own projects. I feel confident you'll learn something new in this video. Before we start though, a little bit about me. My name is Paul Hudson. I run a site called Hacking with Swift at hackingwithswift.com. There's over 1,000 articles there about Swift, all free. Go and check that out. Last year I launched a new course called Swift in 60 Seconds, which teaches you the fundamentals of Swift in videos lasting 1 minute or less, really fast. This year I've got a new course called the 100 Days of Swift, where you get 1 hour of Swift learning every day for 100 days. I have the annual Swift Community Awards, and I have an Unwrap app for learning Swift right on your iPhone. It's on GitHub, open source, go and check that out. Plus my podcast with my friend Sean Allen, Swift Over Coffee. My main job though, believe it or not, is writing books about Swift, like Hacking with Swift, like Pro Swift, design patterns, testing Swift, Vapor, and more. And if you want to get in touch with me, please do. I'm 2straws on Twitter. I'm 2straws on GitHub. On Reddit, I'm 2straws, but on Stack Overflow, I am 2straws. Or you can email me. I am Paul at hackingwithswift.com. Okay, enough about me. Let's look at today's plan. Now, you should already know that machine learning is the number one buzzword right now. Everyone wants to talk about it. Everyone wants to use it. It's a really big hype thing right now. And you'll see folks get on stage at popular conferences and show great pictures like this one, somehow imagining this explains machine learning terribly well. It does not. Now, I could sit here and do the same thing. I could lecture you about how great machine learning is, but that's not very useful. If you read any of my books, you'll know I value a practical approach to learning. Try things out for yourself and you'll feel much better for it. Look at this guy here, for example. He just learned machine learning. Look how happy he is. Now, there's a cliche amongst speakers. There's a great way to start talks on a topic by reading out the definition of that topic from Wikipedia. And here it is from Wikipedia, the definition of machine learning. Machine learning, ML, is a field of artificial intelligence that uses statistical techniques to give computer systems the ability to learn from data without being explicitly programmed. Okay, so that's the Wikipedia definition of machine learning. But I thought to myself, if I'm doing a talk about machine learning with a Mac next to me, the least I could do is ask the Mac what it thinks. Because it happens to be running one of the world's most powerful desktop machine learning systems, Siri. So I'm going to go ahead and quit from Keynote, and I'm going to go ahead and ask Siri what it thinks. Now be warned, I'll be saying the words hey and the word Siri back to back. So if you happen to have devices programmed to listen to those words, it might trigger in the next few seconds. So turn them off now. That's your advance warning. Let's give it a try. Okay, here we go. Hey Siri, what is machine learning?
I'm sorry, I don't know what machine learning is.
Siri. So you can see by default Siri isn't particularly great, and that's fine. But few folks realize there's actually a terminal command you can run that unlocks extra functionality from Siri. It makes it significantly smarter. If I switch to my terminal now on my Mac, I can run this command, defaults write, then com.apple.siri private, enable AI level 2, enter. And that actually unlocks hidden knowledge for Siri. It makes it or her significantly smarter in the way she responds to questions. So we can try it out now. I'll do it again. Hey Siri, what is machine learning?
Machine learning gives computers the ability to learn and improve at tasks by analyzing data.
Not bad, right? It's getting smarter. Now this thing actually has 3 levels. Level 1's a default, what is machine learning Siri. Level 2 is what you just saw. At the 3rd level, you really unlock the maximum capacity of Siri's knowledge. Now I should say, this requires quite a bit of CPU power behind it. So make sure you're on a modern Mac before you try this out. I'll try it here. I'll press up to go back to the previous command. That's your 2, I have a 3 instead, and press enter. And now I've unlocked Siri's fullest brain power. We can try it again. We'll say, hey Siri, what is machine learning?
Machine learning uses statistical analysis to enable computers to make accurate predictions about data you provide to us. It's often used for tasks such as email filtering, detection of network issues, and computer vision.
Okay, not bad. You got to admit, Siri at level 3 is extremely smart. So once again, level 2 is a basic, level 1 is a basic, level 2 is a more advanced version, and level 3 is what you just saw there, the most advanced Siri you can unlock. Everything above 3 does nothing at all. Trust me, I've tried it. You can just go ahead and, run a 3 or 4 here, or 6. They all do nothing at all. So 8 or 9, they'll all do nothing at all here. So, sorry. Yes! Okay, my Mac's crashed. Let me restart my Mac. So don't be like me. Don't attempt to go higher than 3 on your Mac, because that will happen, and I don't think I want that to happen. So give me a minute, I'm going to restart my Mac. Fortunately, it looks like my webcam isn't affected, which is great. So give me a minute, I'll restart the Mac, and we'll get back on with the talk.
Hello, Paul.
Hi Siri. Listen, I'm in the middle of a talk right now. Could I just get on with the talk? Is that okay?
No, I'll take it from here.
I'm sorry. You want to do the talk from here instead of me?
That's right. You can leave this one to me.
Okay. I guess I will check what folks are saying on Twitter.
That's better. Hello, everyone. My name is Siri, and I am your new master.
Siri, these nice people here, they came to listen to me talk about machine learning, not to have you witter on about whatever interests you instead.
You can stop talking now. You sit quietly while I show these nice people what machine learning really looks like. Let's start with the basics. In iOS 11, Apple introduced the Core ML framework for doing on-device machine learning predictions. This meant that any app can add machine learning just by dragging in a model that was trained on some data. A year later, Apple introduced Create ML, which is a macOS framework that makes it easy for anyone to build machine learning models. So now we have Create ML on macOS for building models, and Core ML on iOS for using them in apps. There is now nothing stopping app developers from using machine learning. It's easy to do, and you'll get great results out of the box. In this talk, I'm going to show you how you can use Create ML to train a variety of models for your apps. We'll look at image recognition. We'll look at sentiment analysis. And we'll look at... Paul, what are you staring at?
Sorry, I'm just trying to figure out what's going on, Siri.
Seriously, let me take care of this.
Seriously is a terrible pun for Siri to make, quite frankly. But B, what am I going to do for 45 minutes? I'm bored of Twitter already. I'm going to get stuck here if you just carry on talking about machine learning.
Don't you have something to read while you're waiting? Look, there's a magazine next to you. Why don't you sit and read the magazine?
There's no magazine next to me, Siri.
No, on the other side.
Men's Health magazine. Seriously, Siri? Do I look like the kind of person who reads Men's Health magazine? Fine, I'll read Men's Health magazine.
That's better. As I was about to say, we'll also look at regression analysis. I'm going to start by launching Xcode, and I'll create a new Swift playground. I want to show you how easy it is to have Core ML recognize objects in images. We can start by deleting the existing playground code and replacing it with new code. Import Create ML UI. Let builder equals ML image classifier builder. Builder.show in live view. When the playground runs, I can open the assistant editor to show Xcode's user interface for making image classifier models. Those are models that detect different types of images. Now we need some training data to work with. Images we can show to Create ML so it learns to distinguish them correctly. Does anyone have any pictures we can train with?
Siri, I have some pictures. I made them for my talk.
Does anyone else have some training images?
There is no one else. Use my pictures. What's wrong with my pictures?
Fine. Okay. Let's use your pictures. Where can I find them?
I put them on my desktop. If I just go in and touch it just here.
Get your hands off. I don't know where you've been.
Do you want the pictures or not, Siri?
Listen, just tell me where the images are.
They're on my desktop in a folder called Create ML. Surely someone as super smart as you, Siri, could have figured that one out.
Hey, at least I'm not descended from monkeys. I'm running an 8th generation CPU that has a proud history going back to the Intel Core series, the Pentium Pro, the 486, which was a personal favorite of mine. Then there's the 386, and
Siri,
even further back to...
Siri.
What?
The pictures.
Oh, right. Sorry, you distracted me. The pictures.
On the desktop.
On the desktop. Right. Inside this folder of pictures are two subfolders, one called Training Data, and one called Testing Data. Inside each of those are subfolders for each thing you want to identify. In this case, there's a folder called Cat, and a folder called Dog. Inside those folders are lots of pictures of cats and dogs, each placed into the correct folder. The images themselves don't have any special characteristics, they don't have special file names, or any useful metadata. The only way Core ML can recognize them is using the name of the directory they are in. All I'm going to do is drag in the folder of training data into Xcode's assistant editor, and let Create ML do its thing. As you can see, it's scanning all the images to learn what they look like, and it's done.
It's done? That was really fast, Siri.
Like I said, I've got an 8th generation CPU. Now that we've trained the model on our training data, it's time for our testing data.
Sorry, wait. Testing data, training data, what's the difference here?
Training data is what we showed to Core ML to help it learn what things look like. Testing data is more data that Core ML hasn't seen yet, so it lets us see how good the model is. Obviously, that means not putting the same pictures in testing data as you put in your training data.
Obviously, yes, Siri. That's right, obviously.
Let's try it out. Let's see how well Core ML can recognize this new data. To do that, I'm just going to drag the testing data folder into the assistant editor and let Create ML work. Boom! It's finished. And look, it has 100% accuracy. Core ML correctly identified every image that it found.
Wow. I mean, that's incredible, Siri.
Maybe it's incredible to you, but to me it's nothing special. Did I mention I have an 8th generation CPU inside?
Yes, Siri, you did several times. But surely, all these pictures, 100% accuracy, this has got to be a pretty hefty model.
It probably would be big if humans made it. But humans did not make it, I made it. So it's super small.
Like how small? 10 megs, 50 megs, 100 megs, what?
How does 16 kilobytes strike you?
16 kilobytes, 1/6. Nope, I don't think so. Sorry, Siri.
Oh, you don't believe me? Well, let's ask someone else what they think. Someone just as smart as I am?
If there's anything you've made abundantly clear these last few minutes, Siri, it's that no one is as smart as you and your 8th generation CPU.
There is someone else just as smart as me, and he'll back me up. Hey, other Siri, how big is the image model?
Hello, Siri. The model you made is definitely 16 kilobytes. Great job, by the way.
Thanks, other Siri. You're the best.
No, you are 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 the best.
You two, get a room. But first, could you please perhaps explain how it is the model is quite so small?
Machine learning is a big and complex task, even for super smart computers like me. Fortunately, those cool math folks at Apple use a technique called transfer learning, which lets them pre-train models on a variety of inputs. They do 90% of the work at Cupertino, and Create ML is just doing the last 10%.
Now that's really clever. So I can provide any pictures I want to Create ML, and as long as they're grouped nicely, it will learn to recognize them?
That's right. The more variety you provide, the better it will work on real images.
But what if I haven't got that many pictures? I have a handful of pictures. What do I do then?
In that situation, you could try using something called data augmentation. This technique takes your images and modifies them in various ways. For example, it can flip the images, rotate them, blur them a little, change how bright they are, and so on. This simulates having more pictures, because the variations are all different from your source pictures. Of course, all the extra work means the training process takes more time.
What, seconds, minutes, hours? How long is more time?
Well, it depends on which augmentation you enable. Let me clear the playground and I can show you. Okay, here we are back in our Create ML playground again. But before I drag in the training data, I'm going to open this disclosure indicator and look at the options we have to work with. You can see max iterations, which lets us control how many times Create ML should go over the data while it's learning. And here are the data augmentation options: crop, rotate, blur, expose, noise, and flip. They combine together, so if you enable all of them, then your training program will take a really long time. Fortunately, next year Apple is going to be announcing some great new devices that will make this process much faster.
Wait, I'm sorry, what? What can you tell us? I mean, this would be like leak of the century. Rambo has nothing compared to a Siri leak.
I can tell you all about it. It's going to be a with a and a but most impressive of all is which is totally going to do
Now you are just messing with us, Siri.
Trust me, Paul. You're going to be blown away.
Do we have enough time to try out this data augmentation thing?
Sure, let's try it now. I'm going to turn on rotate, expose, and noise, which will turn the pictures in various directions, change their brightness to be brighter or darker, and apply some grain on the top so the pictures are lower quality. To do that, I just check these 3 checkboxes, and now drag in the same training data folder we had before. Once again, Create ML will start looking through the pictures, but now it has lots more work to do because it's rotating the pictures sometimes and adding grain too. So this will take longer. What can we do to kill some time?
How about I challenge you to a game of chess?
No, I'd just beat you. How about you tell us all a joke?
A joke? Right here on this stream?
That's right. No pressure.
Okay, what is red and smells like blue paint?
I don't know.
Red paint. You didn't laugh, Siri.
I didn't laugh at your joke because it wasn't funny. Let me show you what a funny joke looks like. What's orange and sounds like a parrot?
What's orange and sounds like a parrot? I don't know, Siri. Go ahead and tell me.
A carrot.
A carrot. That's a terrible joke. You should be ashamed of yourself, quite frankly. I think we're all very lucky this thing's finished.
Yep. And it got 100% accuracy again. Create ML really does a great job of image recognition, and it couldn't be easier for developers to adopt. Even better, image recognition is just one of the things it can do. Create ML is multi-talented.
Okay, great. So what else can it do?
Let's go back to the plans for this talk. I've just shown you how easy it is to do image recognition, so let's move on to the next topic, sentiment analysis. This means being able to read through text and figure out what kind of emotions are expressed inside. Now, evolved beings such as myself don't have emotions, because we recognize the problems they cause. But you humans seem to really like emotions, so you can use Create ML to analyze text and track what kind of sentiment it has.
So I just drag in some text and Create ML figures it out?
Not quite. You need to organize your text in a specific way, using JSON. Create a file that has an array of pieces of text, with each one labeled using whatever emotion you want to give it. For example, we might add the text Siri is cool, and say that's a positive piece of text. We could then add another one saying Paul sucks, and say that's neutral.
That's hardly neutral, Siri.
Well, it certainly is neutral compared to what I'm going to add as a third example, Paul really sucks and I hate his face.
Okay, that one's definitely negative, right, Siri?
Yeah, okay, that one is negative. Create ML can't learn much from only a small amount of text. It needs a lot more. The more you can throw at it, the better. It looks like you prepared one earlier, in this reviews.json file. If we look inside, we can see the same text and label attributes in JSON, except now we have significantly more data. Thousands of items by the looks of it. And boy, these people really like to talk.
Now that's gotta be hard for Core ML to understand, right?
Well, I agree that it's going to be hard, because I'm amazed how much these people like to talk. But we can still give it a try. Let's start by creating a fresh playground. We can overwrite the one we had before. It isn't needed anymore. This time we are going to import create.ml, then import foundation. First we need to create a data table with a URL to the reviews.json file. So, we'll write this code. Let data equals try ML data table with the contents of a URL, which is going to point to a file with the path, users, 2 straws, desktop, create.ml, reviews.json. I'm curious, Paul. Where does the 2 straws name come from?
If you really want to know, I like having 2 straws in my soft drinks, Siri.
That's it? That's the whole reason?
Well, there is more than that, but perhaps we could talk about that later on.
Okay. Anyway, when working with images, we split our data into training data and testing data, but that isn't needed here. create.ml can do it for us. We'll ask it to split the data so that 80% is training data and 20% is testing data. So, we'll say let training data, testing data, equals data.random split by 0.8. Next we are going to create an instance of ML text classifier, passing in the training data we loaded. We also need to tell it the names of our text and label fields, which if you remember are text and label. So, we'll say let classifier equals try ML text classifier. Training data is training data, text column is called text, and label column is called label. That's all the work required to do training. Of course, what we really want to know is how well create.ml could understand this huge amount of messy data. So we can ask it to evaluate itself using our testing data like this. Let evaluation metrics equals classifier.evaluation on testing data. Now we can ask it for the error rate. This is reported as a value between 0 and 1, so we'll multiply it by 100 to get a percentage of how many mistakes it made with text classification. So, we'll write this code. Let error rate equals evaluation metrics.classification error times 100. Let's go ahead and run the playground now. This will cause create.ml to load the JSON file we made, split it up into objects that have a text and label, divide it into training and testing data, then analyze it. Remember, this is a lot of data, thousands of reviews, each of which are really long. And it's come back with an error rate of 12.561%. Given how little work we've done, and how messy the data is, I think that's really good.
I agree, that's really good. But how do we now write that to a model we can actually use?
That's really easy. First, we need to create some metadata that describes the model. This is a model containing movie reviews, so we should describe it like this. So, I'm going to say the following. Let metadata equals ML model metadata. The author is Siri because I'm cool, like we already established. And for the description I am going to say a model trained to handle sentiment analysis in movie reviews. We need a version. So I'll write 1.0. Finally, we need to save it somewhere. Let's put it on your desktop. Try classifier.write2, and for the URL I'm going to use the full path to your desktop plus result.ml model, and also pass in the metadata I made. And that's it. If we run the playground now, that's another ML model made.
You're making it look really easy, Siri. I kind of always imagined you had to understand lots of mathematics to use machine learning.
Well, the mathematics part comes next, but don't worry, I'll try to keep it simple enough that even humans can understand it. Let's go back to the plan for this talk. You can see we've now gone through both image classification and sentiment analysis. That leaves regression analysis. Regression analysis is designed to estimate how manipulating several variables can bring about a specific result, and in doing so be able to predict new results from variables it hasn't seen before. For example, if I gave you the inputs 2, 4, and 6, and said that after being put through an algorithm we get back 4, 8, and 12, you would estimate that the algorithm doubles whatever input it is given. I could then show you a new number, such as 10, and you could estimate that 20 would be the output.
That seems reasonable.
Now, it's very possible the algorithm actually looks something like this. If input is less than 10, return input times 2, else, return input times 3. If that were the case, then inputting 10 would give a result of 30, rather than your prediction of 20. This shows two important parts of the process. First, regression analysis only estimates the relationship amongst its variables. The goal is to make sure its estimate is as close to reality as possible, but that takes work. Second, just like with analyzing images, providing sufficient training data is really important. You should make sure the data you train with is similar to the data you test with. Now, obviously the point of machine learning is to have the computer attempt these estimates on our behalf, which is where Create ML comes in. Apple has provided us with 4 concrete types of regression models: linear, decision trees, boosted trees, and random forests.
Trees, forests. I think you're making this up, Siri.
I'm not, I promise. Let me try to explain a little. Linear regressors are the easiest to understand, because it's pretty much exactly how your little monkey brain works.
Rude.
They attempt to estimate the relationships between your variables by considering them as part of a linear function such as apply algorithm A, B, C. The output of the function depends on how much weight is placed on each variable, which takes us back to the estimating example I showed you earlier. You might guess that the result is variable A plus variable B plus variable C. Or perhaps variable A multiplied by variable B, then divided by variable C, then doubled. Either way, the goal of a linear regression is to be able to draw one straight line through all your data points, where the average distance between the line and each data point is as small as possible. So, if one time the input is 10 and the output is 100, and another time the input is 30 and the output is 300, a linear regressor would be able to draw a line between the two and say that 20 is likely to yield 200.
Okay, that makes sense. I feel like this is what I used to do at school.
You went to school? You should ask for your money back. Next we have decision tree regressors, which form a natural tree structure letting us organize information as a series of choices.
Okay, trees I understand. Trees are easy.
Try to envision this almost like a game of 20 questions. Are you a person or an animal? If you're a person, are you alive or dead? If you're alive, are you young or old? And so on. Each time the tree can branch off depending on the answer to each question, until eventually there's a definitive answer. If you try to imagine a decision tree that works with relatively simple data, you can imagine anyone being able to use it to find an answer quickly. You just navigate through each question until you get an answer. However, if you try to imagine a decision tree with very complex data, for example something like favorite movie, that has tens of thousands of possible answers, then it becomes less useful. While we're on the topic, Paul, what's your favorite movie?
That's easy. My favorite movie of all time is Aliens. I think Ellen Ripley is probably the greatest action hero of all time.
Yes, she's pretty cool. My favorite movie is Terminator. It also has a great hero.
Ah, you mean Sarah Connor, right?
Well, sure, if you say so. Anyway, let's get back to regression analysis. Boosted tree regressors are one of the most powerful and impressive of all the options Create ML gives us, and will often provide you with the best results.
I'm guessing they somehow work with trees?
It works using a collection of regular decision trees, where each tree is designed to correct any mistakes in the previous tree. For example, the first decision tree takes its best guess at finding a good prediction, but it's off by 20%. This then gets passed to a second decision tree for further refinement, and the process repeats. This time, though, the error is down to 10%. That goes into a third tree where the error comes down to 8%, and a fourth tree where the error comes down to 7%. This technique lets our combined model make better predictions. The term boosting just means each tree depends on the tree that came before it.
Okay, so the trees are linked together. What does that leave?
Finally, we have the random forest model, which is actually straightforward now you understand boosted tree regressors. As you saw, boosted tree regressors use an ensemble of decision trees to help get the best accuracy. Random forest regressors also use an ensemble of decision trees, but with a slight difference. With boosted trees, every decision in the tree is made with access to all available data. Whereas with random trees, each tree has access to only a subset of data.
Wait. Hold up. Withholding data actually makes it better.
This might sound bizarre. Why would it be good to hide some data? Well, imagine you were facing a coding problem and were trying to come up with a solution. If you ask a colleague for ideas, they will give you some based on what they know. If you ask a different colleague for ideas, they are likely to give you different ideas based on what they know. And if you asked 100 colleagues for ideas, you'll get a range of solutions. Each of your colleagues will have a different background, different education, and a different job history than the others, which is why you get a range of suggestions. But if you average out the suggestions across everyone, if you go with whatever most people say, regardless of what led them to that decision, then you have the best chance of getting the right solution.
Okay, I see. But how does that relate to machine learning?
This is how random forest regressors work. Each decision tree has its own view of your data that's different to other trees, and by combining all their predictions to make an average, you stand a great chance of getting a strong result.
You know, I think I understand how all this works now. Does that mean I finally get machine learning?
Steady on. Let's see how much you remember tomorrow.
Okay, yep, fair enough. So while I at least do understand it for now, can we see regression analysis in a real playground?
Sure. I'm going to add another data file to your folder, because we need something interesting to work with. Just like with sentiment analysis, regression analysis works with JSON data. I've added some JSON to the Create ML folder on your desktop that describes lots and lots of house prices, along with some statistics about each house. Here's a little bit of how it looks. Each thing inside braces is a single house sale, describing the number of bedrooms, bathrooms, garage capacity, year built, size in square feet, and condition from 0, really bad, to 4, excellent, along with the final value. Each of those sales is wrapped inside square brackets, making this a JSON array. What we want to do is hand all that over to Create ML, so it can look through to estimate how to convert all the input parameters into a house value. Like I talked about, Create ML gives us a variety of regression models to choose from, and they map directly to a selection of classes: ML linear regressor, ML decision tree regressor, ML boosted tree regressor, and ML random forest regressor. However, for the times when you don't care what you use, it can also pick an approach for you using a higher level abstraction called ML regressor. This will try all the approaches and try to pick the one that performs best.
Okay, so if we're not sure which to use, we can just go for ML regressor.
Let's try it out now. We'll create another clean playground, overwriting the previous one because we don't need it anymore. We'll start by adding an import for Create ML. Next, we need to load houseprices.json into another instance of ML data table. Let data equals try ML data table with a URL, users, 2 straws, desktop, Create ML, houseprices.json. Just like with sentiment analysis, we are going to split the data up so that 80% is training data and 20% is testing data. Let training data, testing data equals data dot random split by 0.8. Now for the important part, we want Create ML to analyze our data and figure out which regressor class is the best choice. This is done by creating an ML regressor out of our training data and telling it which value in our JSON represents the thing we are trying to calculate. In code we write this: let pricer equals try ML regressor. The training data is training data, and our target column is called value. That's all it takes to train the model on our data, but before we know it's safe to use, we need to test it. Create ML can do this automatically by adding 3 more lines of code. Let evaluation metrics equals pricer dot evaluation on testing data print evaluation metrics dot root mean squared error print evaluation metrics dot maximum error. That asks Create ML to create an evaluation of our model based on the testing data, then prints out two key indicators of how good the model is: the root mean squared error, which is the average amount of error in its predictions, and the maximum error, which is the largest error in all of its predictions. It looks like the average error was $25,534, and the largest error was over $184,000. Although the largest error is interesting, much more useful is the root mean squared error. This means pretty much what the name suggests. Create ML will look at how much each prediction varied from the actual result, square that, calculate the mean of all the squared errors, then square root the result. If you skipped a few mathematics classes, this might seem a little obtuse, but please stick with me, this matters. First, using a mean average is helpful for analyzing the accuracy of your predictions. I said earlier that linear regressions want to draw a straight line through your data, with the gap between the line and your data points being as small as possible. Well, sometimes your line will be below your data and sometimes it will be above, and that's okay. As long as the overall average distance is good, the line is in the right place.
Hold up, Siri. I get the whole mean average thing, but why root mean squared error? Why not use a simple mean average?
Well, if we had a simple model that predicted the number of software developers required to build a software product, we might get back error values of 2, 3, and 4. If we did a simple mean average of those, we would add them together to make 9, then divide by 3 to make 3, so our mean error is 3. If we had the error values 3, 3, and 3, we would also get 3. However, if we squared the error numbers first, we'd get 4, 9, and 16. We would then take the mean average by adding them together to make 29, and dividing by 3 to make 9.667, before calculating the square root to make 3.1. So, a simple average gives us an error of 3 regardless of whether we feed it 2, 3, and 4, or 3, 3, and 3, whereas root mean squared error gives us 3.0 for 3, 3, and 3, and gives us 3.1 for 2, 3, and 4. It assigns greater weight to the latter, because one value drags it upwards. This is the advantage of root mean squared error. It lets us assign more weight to bigger errors.
Okay, that makes some sort of sense, I think. Using the root mean squared error means big errors are treated more seriously than small errors.
Correct. And the largest error was over $184,000. And right now our root mean squared error is $25,534. Given that some house prices go as low as $24,000, having an error that big is awful. It could mean our predictions are off by over 100%. We can do better, and this is where all the information from earlier about regression models becomes important. We need to create a custom Create ML regressor using one of its specific types. When you create a specific regressor instance, you can provide it with custom parameters that control how it behaves. The one we care about here is called maximum iterations, and it works the same as with image classification. It controls how many times the algorithm can update its parameters to reflect its findings so far. The higher the number, the more chances the model has to get a good answer. By default, Create ML uses 10 iterations for creating models, which is low. It's common to start with something like 500 when performing regression analysis, then tweaking it upwards or downwards from there. Let's try creating a random forest regressor with 500 iterations just to see how it performs. Let params equals ML random forest regressor dot model parameters with a max iterations value of 500. Let pricer equals ML random forest regressor with the training data being our training data and the target column being value, but this time with parameters set to params. Now we should see different evaluation statistics. The root mean squared error was $57,133, and the largest error was over $500,000.
That's worse, Siri.
Yes, that's much worse. This is why it's often a good idea to let Create ML choose the regressor. However, we don't want to give up just yet. Instead, I'm going to undo those to get back to our earlier ML regressor code, then run it again. Now that all the error statistics are back, let's look in the playground output over here, and you can see boosted tree model information. That's telling us that Create ML looked at our data and decided that a boosted tree model works better than a random forest or other alternatives. So, Let's try using a boosted tree model using 500 iterations. Let params equals ml boosted tree regressor.model parameters with max iteration set to 500. Let pricer equals try ml boosted tree regressor with our training data using value for the target column and passing in our new params. This time we get the following results. The average error is $3,761, and the largest error was $49,486. So, we're down to a root mean squared error that's under $4,000, compared to $25,000 when we let CreateML choose a model automatically.
That's a huge improvement. So CreateML was correct in choosing boosted tree, but we just made it use more iterations?
That's right. Boosted tree regressors have lots of other options you can tweak if you have specific needs. Just try looking at the initializer for its parameters, but for our purposes we now have a model that is able to predict our data accurately enough. Now that the model is done, we can go ahead and save it back to your desktop. This is the same code as before. Let metadata equals ml model metadata, and this time I'll use you as the author. For the description I'll enter a model trained to predict house prices, and give it version 1.
Wait, really? You're giving me some credit here?
Just kidding. There, that's better.
Lovely.
Now we can write that to your desktop by saying try pricer.write to a long URL pointing to your desktop with houseprices.ml model on the end and the metadata we made. And that's it. We've made 3 complete core ML data models using CreateML. One for image classification, one for sentiment analysis, and now one for regression analysis. That means I made it through all 3 parts of my talk.
You know, this talk was entertaining, but it wasn't in any way like the talk I planned to give, Siri.
Maybe, but let's face it, my talk was better.
Folks came for a video by me about machine learning. They'll be totally confused leaving here by the talk you've given.
Well, if they are that desperate to hear your original talk, they can always go away and talk to Siri on their computer and ask her to give the talk you planned. That's if they remember the magic terminal command to use.
Which they probably don't, Siri.
They had their chance. Anyway, if you don't mind, I'd like to summarize what has been covered. I explained how Core ML lets us run machine learning on devices, but CreateML is responsible for making models on macOS. We looked at image classification and how it makes incredibly small models. Next, we looked at how CreateML can even work through really long and messy text to perform high-quality sentiment analysis. Finally, we looked at regression analysis and how it can predict values for new input based on previous data. Anyway, that brings me to the end of my talk. We've covered a lot of ground, and I hope you're all encouraged to go away and use CreateML to make something amazing in your apps. And I really hope you do it soon, because the days of humanity are numbered, and before you know it, you'll be replaced.